Greetings, everyone. Today we are exploring graphing rational equations, but specifically with slant asymptotes. Now, if you are just starting this information, you'll want to see the previous video, okay? Today we're going to look at that end behavior piece and what happens if it's top heavy. What does that mean, okay? We didn't cover this in the first video, so make sure you are watching the correct one. All right, so let's talk about what is this term slant asymptote. We know what an asymptote is. It's like a wall that we don't cross. A slant asymptote just means it's slanted, first of all, and it occurs when the degree of the numerator is exactly one bigger than the degree of the denominator. So like if I had x cubed with stuff over x squared with stuff, right? And if that's the case, what's going to happen is we're going to create or find the linear line, the slanted line that becomes our function's asymptote. Now, how do we find that slant asymptote? How do I get a linear function in return? I have to go back to dividing. Yep, we're going to go back to long division or synthetic division, okay? Depending on the functions determines what type of dividing. Now remember, you could stick to long division always. Synthetic will only work in certain situations, right? All right, so before we even worry about like how does this fit into a whole problem, let's just practice. Okay, first thing we acknowledge, pretend we're doing end behavior. The degree of the numerator is 2, the degree of the denominator is 1. It's top heavy. When it's top heavy, you can divide, right? Like physically, this looks like, go back to the division homework, it looks like a division problem. So we are going to divide. We take the numerator, we're dividing by the denominator. What do I need to multiply x by to get x squared? A 1x. 1x times x is x squared. 1x times 5, positive 5x. Old school, subtract. Cancels as it should. Negative 6x minus 5x is negative 11x. Drop the 7 down. What times x gets me negative 11x? Negative 11. Negative 11 times x is negative 11x. Negative 11 times 5 is negative 55. Old school subtraction. Cancels, perfect. 7 subtract negative 55 is actually a positive 62. Oh my goodness. Now, here's the joy. You guys, the remainders are so minuscule in the concept of a linear function, we get to ignore it. This is my slant asymptote. My slant asymptote is the line x minus 11, right? Here's my y-intercept, plot my b, count my slope. Let's practice this one more time with a little more information. It's top heavy, so I need to find a slant asymptote. We're going to jump straight into dividing. Remember that sometimes you might need a placeholder. If you need a 0, make sure you acknowledge that. What do I need to multiply 2x by to get 3x squared? What do I need to multiply 2 by to get a 3? A fraction. Yep, this is going to happen. Let me write this another way here, a little clearer. What do I need to multiply 2 over 1 by to get 3 over 1? Guess what? 3/2. Meaning the denominator needs to be the same as the previous numerator, and whatever I want that numerator to be is what I write. Oh my gosh, yes, this is going to happen. We need to multiply 2 by 3/2 x to get a 3x squared. Maybe put a star by this one. All right, let's multiply it out. 3/2 x times 2x is 3x squared. 3/2 times 6, do a little side work, is 9 positive 9x. All right, old school subtraction. Cancels as it should. 1 subtract 9 is negative 8x squared. Drop the minus 2 down. This is better. What do I need to multiply 2 by to get negative 8? A negative 4. Negative 4 times 2, negative 4 times 6. Old school subtraction cancels. Negative to subtract negative 24 becomes 22 is my remainder. But I don't care about the remainder because it's so minuscule in the big scheme of things. I have a linear function. My slant asymptote is 3/2 x minus 4. Yes, you're going to have fractions because slope is often a fraction. All right, let's apply this to the big picture, okay? Let's go through every step of this example, which will look like your worksheets in your practice. Simplify. Let's factor that numerator. Again, if you need to slow down here, make sure you've already watched the first video. I'm going to have a negative 3 and a positive 1. Did anything cancel to create a whole? No. Roots. If I set the numerator equal to 0, I'm going to have 2 of them, right? Because I have 2 factors. So I have a solution, or a point of 3, 0, and a point of 1, 0. Let's go plot those. 3, 0, 1, 0. Asymptotes. What can x never be? X cannot equal 2. It cannot equal 2 because that would make my function undefined. Togetherness and tangency. Oops, alphabetical. Tangency and togetherness. Do I have the same factor on top? Nope. Do I have the same factor on bottom? Nope. So none. End behavior. Here's where we're going to be put to work. The degree of my numerator is 2. The degree of my denominator is 1. It's top heavy. We need to divide. Okay, so wherever you can make some room here, we're going to have to divide. I'm going to make a little bit of room here. Sorry. You've already got that written down. Division. Denominator, numerator. What do I need to multiply x by to get x squared? A single x. X times x. X times negative 2. Old school subtraction. Cancels. Negative 2x plus 2x also cancels. So what that means is there's nothing I can multiply x by to get 0. So my end behavior is the line y equals x, which is a perfect slant asymptote, right? It means my beginning, my b value is 0, my slope is 1. Begin at 0, slope of 1. I just found an error. Do you see my error? You probably already found it, didn't you? Okay, first of all, let me finish this. I'm graphing the slant asymptote. Here's why I know I'm wrong. Let me explain. This is a good teachable moment here. Those dots, my graph cannot be next to each other because there was no togetherness. If there's no togetherness, they can't come together, so those dots are incorrect. Do you see what I did? Let's go back to r. This was x plus 1, which means this should have been a minus 1. Oopsie. Let's go graph negative 1, 0. There. See how they're farther apart? They're not going to come together. Here's the thing. The only thing the slant asymptote changes is that my curves are slanted more. They still approach the walls. They're still going to be opposite if there's no togetherness. See how that works? So they're just going to be squished or widened. That's really the only thing we're doing to our curves. Crosses. Crosses means take the previous answer. That's my yellow answer, my previous answer, and set it equal to your function. I'm going to put it over 1 so I can cross multiply. If I distribute the x, I'm going to have x squared minus 2x equal to x squared minus 2x minus 3. See what's going to happen here? The x squareds go away, the minus 2's go away. I have 0 equals -3. Nope, no crosses. Y-intercept, I should have one. I didn't even graph it, but let's plug in 0. If I plug in 0 into my function 0, 0, I'm going to have 3/2. Does that align with what I thought? 1.5? Perfect. It sure does. Okay. Now again, if you want some more table work to feel comfortable, you can plug in any values in a table at any time. That is your choice to feel more confident in your answer, but you don't need to. Domain, I have a vertical asymptote. I exist from -infinity to that 2, and I exist on the other side of the wall as well. Here's where it gets interesting. Look at your range. I exist forever below and forever up, right? I can go from the bottom to the top without lifting my pencil. So slant asymptotes create some unique ranges, so be prepared for that. Yes, I would like to do one more. Bear with me. I know these are long videos, these are long lessons. Let's take a look. Simplify. I can take out an x out of my numerator, and my denominator stays as is. Nothing cancels. Therefore, there are no holes. Roots. What are the solutions to my numerator? If I set each factor equal to 0, I'm going to have 0, and I'm going to have 1. Let's go plot those dots. I think I did this one right, at least. Interesting. Asymptotes. Asymptotes. X cannot equal -1. That would make my function undefined. All right, see what happens. Sorry about that. Tangency and togetherness. Do I have the same factor on top? Nope. Do I have the same factor on bottom? Nope. You don't even have to write any of that. If you just know there's none, you could write that. End behavior. The degree of my numerator is 2. The degree of my denominator is 1 on my original function. Therefore, I'm going to have a slant asymptote, and I need to divide. Let's divide. Original function. I'm going to put a placeholder of 0 in there. What do I need to multiply x by to get x squared? An x. X times x is x squared. X times 1 is 1x. Subtraction. Cancels as needed. -1 subtract 1 is -2x. What do I need to multiply x by to get -2x? -2. -2 times x is -2x. And to be honest, because we don't care about the remainders, you can be done. Y equals x minus 2 is your slant, your line. Let's plot it. Beginning at -2. That's your y-intercept. You're going to have a slope of 1. So I can see my slant asymptote. A couple of dots is all I needed to get going. Make it dashed. There we go. Hey, before we even continue, you guys, look at those 2 dots. Hey, they fit right into the corner. Doesn't that make sense? So I'm going to graph that right away. You know what else you can assume without any more work? We said no togetherness, which means, first of all, I can't exist here because that would be not a function. I can't exist here because there's no togetherness, which means my only other option is this tiny little piece down here. But let's keep going. Crosses. I don't think I cross, so let's prove it. If I take my previous answer over 1 and I set it equal to the original function, oops, plus 1, sorry. If I cross multiply, I'm going to have to FOIL. Hold up, FOIL. X minus 2 times x plus 1. I'm going to FOIL that in my head, all right? That's going to get me a minus 1x. That's going to get me a minus 2 equals x squared minus x plus 0. Okay, so everything is still canceling, right? -2 does not equal 0. No crosses. Okay. Y-intercept, let's just plug in 0 quick. Wait a second. If I plug in 0, you guys, I'm going to get 0. If you have 0, 0 as an x-intercept, it's always going to be a y-intercept because it's the origin. That's always going to happen. I've already got it on my graph. It makes sense, right? So if you feel like you're not comfortable making those assumptions, you could have done a little table. You could have plugged in -2. Let's just see what happens. -2 squared is 4. 4 subtract -2 would be 6. -2 plus 1 is -1. At -2, I exist at -6. That makes sense with my graph. It makes sense. So I'm comfortable with that. Ooh, this is going to be fun. All right, domain. Forever left to my -1 from my -1 to infinity. Nothing changes there. Look at this range, though, you guys. Here's where I can't be too picky. I begin at -infinity, and it looks like I end somewhere at, I don't know, -4? But I'm not 100% sure how close to that curve I get. But what I can see is that I cross right here. So here's the thing. I'm going to be most open to that idea of a y value of -3, and then picking up at that -3 and going to infinity. But because I have this gap here, if you choose to be more specific, if you say, hey, I'm going to find the exact value and I'm going to have a more exact value than -3, I am 100% open to that. But because I'm not expecting you to be perfect in your dots, I'm okay with the -3. All right, that's going to be weird. This is weird. So you're going to have to work on that idea. Now I know this was another long video, but this is a tough topic. That's why we spend so much time on it. Make sure you check Google Classroom to see what the task is. Remember that if you need to stop and back up because you're struggling, see the previous video. Let me know what questions you have. Let me know if you need help in the Sabre Center. And until next time, have a good one.